This conference will now be recorded.
Share the screen. All right. So let's see that, you know, uh, let's continue the topic which we saw last week. It was the demand sensing, which works on the product location and customer level. So let's go to the profile. Let's quickly revise whatever we have seen. So I'm going to an app called as Manage Forecast Models. So inside this, I'm choosing the planning area to filter it out. Otherwise, there will be so many profiles created. Yeah, so this is our planning area. I'm pressing go. So these are the ones. Out of these, we have this HSC demand sensing. This is the one we created with the periodicity as the day level. And now this is the profile which we created. And if I go to the forecasting steps, so we have taken requested quantity, and there were other parameters also we have saved in. So we have told to the system consensus forecast. So whatever the stats forecast we have generated it as, as a result of 12 months of forecast, it should generate in the statistical forecast. So that result, it is taking into consideration the snapshot of it, and also it is taking the bias horizon, meaning it is taking weeks in the past for which the recent historical, this bias is calculated, and this is used as an input in the forecast bias. And so bias is something, you can understand in simple terms, that forecast bias will help us to estimate if there is any over forecast or there is any under forecast, right? It can be lot of forecast, right? um, than the required actuals, or it can be very very less as compared to the actuals. So both are the bias situation in this case. So we'll see that, they will take the bias in the range of 1 to 10. So um, that will just go on a rolling manner. And just to understand what is bias, it is the tendency to measure if it is a over forecast or it is a under forecast. How do we measure the over forecast? Because we have a baseline of actual, and if it is very much above the actuals, right, the forecast is very very much above the actuals, then it is over forecast. And if it is very low than the actuals line, then it is the uh, under forecast. So both ways it will lead to an forecast error. To measure that tendency, this bias is there. And then we also discussed that how much we can deviate it from our demand planning quantity. So let's say that demand planning quantity is 100. So sense demand can be 100, or it can be little bit varied between this range. So last time we took it 50-50. Normally by default it will be 50-50. It means that we are putting a cap on the sense demand, that it should not vary much as compared to the earlier forecast that we have created in the as a result of stats forecast, which gets copied to the demand planning quantity. So our consensus demand should not be much varying with the sense demand. So sense demand should be, in that particular range uh, of your consensus demand. So we'll also see, going forward, we can also set up the alert that the consensus demand versus sense demand, uh, you know if there are some differences, because we have lot many products. um, we have lot many products. Good. That we cannot manually keep an eye on that, so we can just generate the custom alert where we can just compare that the consensus demand, how much it varies from the sense demand, right? So last time what we did not do is, so this was a quick uh, recap of this, what we have generated last time. So what we did not do is, we did not executed that. So execution is in the same way. So for example, if I go to the demand side template, in this we can take all the inputs, and then we can also take the output. So requested quantity, and then confirmed quantity, delivered quantity, all this will come from your S4 system or ECL system, and this is already sitting here. So now let us execute this sense demand quantity. So this stats forecast quantity is the previous one which we are using. So what we have told to the algorithm, that we have told that whatever is the stats forecast quantity, it should not be much varying the sense demand quantity, just plus minus 50. So it can little bit variate based on the input that we are giving, but it won't uh, you know variate much. So how to execute it is in the same way, that I'm going to the stats forecast, I'm running it, and then this will calculate at the level of product, location, and then customer. So this works on PLC um, base, and then this one periodicity we have taken at a day level, right? So if we see our forecast, if I go in the general section, so here we have given the periodicity at the day level. So forecast to be used is, this is the one which we have, ZHSC demand sensing. So this is the forecast profile. So if you want to see what is the name, so this is the name of the um, algorithm that we have designed. And then in the filter, let me just say it for one product. We already have this, so IBP 100. So I'm saying run. Okay. So in the meantime it runs, let us also discuss that, uh, you know, how do we, uh, what are the steps that we follow during the implementation of this. So demand sensing implementation. So first thing is, what we have done is, uh, you know, we the first step will be to load all, data related to your sales orders. So you may have the historical sales orders, or you may have the future sales orders. All of that data you will bring and then load it. And then you will create demand sensing profile as the way that we have created. So we created this profile ZHSC. So like this, you will create your profile. So create two profiles. One is in the full mode and other is in the uh, update mode. So what you do is uh, in the beginning of each week, you can say start of each week we can execute full mode demand sensing. Now let's say that in the starting of the week, let's say that today is Monday, is the first working day of our week. I have executed this, right? Next Monday again this will run the full mode. But what happens if there are new sales order coming up on Tuesday, Wednesday, Thursday, Friday, right? I want to consider them also. So whatever delta is coming, right, that I can execute it with the help of the update mode. That I can do daily run. So let's say on Monday this has run. So from Tuesday to Friday, I can just run daily run of update mode. So this will consider all the delta portion of the orders coming in, right? Of new orders. Either it could be new orders or there are some changes to existing orders. Let's say that there was an existing order of 100 quantity. Now the quantity has been updated to 120 units. So definitely it's a change, and that change also should be considered. So that will be considered in the update mode. If there is a change in the date, that also can be considered in the update mode. Any delta changes which are happening to the shipments, orders, open orders, that will be considered by this job. And then you just these are the 5 steps. If you follow, this will be implemented, right? So now we are going back to this one. Let me refresh it. So now we are in somewhere around 40s week. Yeah. So now here you see that you know this was my stats forecast which was calculated for this product, and then the demand sensing is also coming on the line of this. It's not much deviating, a little bit. It is 90, this is 95. So this is you are getting the output in the sensed quantity. So maybe this may not be the very good example just to see that, but in real time, whatever orders are coming when it is connected to the source system, the real orders will be coming, the changes will be happening into the system, and that will give you much more realistic forecast. But still you will be able to see here in this test environment that sense demand is something that it has calculated as an output when we have executed the full mode algorithm. So just remember, full mode will run on everything, right? It will consider all the orders. And then delta mode. So how do we choose the full mode and delta mode while designing this? So maybe this one we have designed it for full mode. One more copy we can do, and then we tell to the system that this is a delta mode. Yeah. So this is the full. And then if I just want to make a delta mode as well, so what I'll do is, so wait a minute, I think I cannot add two here. That's the thing with the demand sensing. So for a moment I'll just remove this, just to show you that there are two algorithms available. So now if I go down, so now you have this full mode, and this is the delta mode, which is the update. So these are the two ones which we just talked about here. These are two profiles we can create. So the, inside algorithm will remain same, but the way that it works in update modes, it will consider all the changes that has happened. So you don't have to wait till the next Monday to again run this whole job. If you just run update, it will be pretty fast. Why it will be pretty fast? Because update means whatever the changes it has done, only those it will consider, and then pretty quickly it will just finish it on the daily basis. Only on the weekly runs it will be little taking more time. So you can schedule it during the weekend, so that on Monday when you come you will have the business can see the results from the weekly ones. Then from Monday, uh, Tuesday onwards, again that update will start. So I'm not saving this. Let the other one which was there.
HS, the full mode was only
Yeah,
the first time, or every week of the Monday you have to do full mode?
yeah, yeah. Every week. It is not one-time activity. It will be the repetitive activity, but every week you can do that in the start of the week.
Okay, okay.
Let's say every Monday. Yeah, and then Tuesday, Wednesday, Thursday, Friday, you can run the other one, which is the update one. So two profiles you can just create. That's it. All right. So this will just give you the more accurate forecast when you. But the thing is that you should make sure that all the jobs which are loading the sales order related data, the requested quantity, all that is finished. So in the training system, what you have to make sure is there is some important master data to run the demand sensing. So if I go to the master data workbench, so you have something called as this one, demand sensing order fulfillment. So you don't have to remember this. If you just go to the master data, you will see that you have something related to demand sensing order fulfillment. You go there, and you know you will see that how many number of days for that order fulfillment, um, you know you are actually giving it here. So what is the meaning of this? The meaning of this is, if you just see this particular key figure, which is requested quantity. So requested quantity, if I go to the edit mode and I go to the key figures, I put my cursor here, it will show you that this is at the level daily, product, location, customer, and DS fulfillment. DS fulfillment means demand sensing fulfillment. So this DS fulfillment is nothing but your this master data. So just remember that you need to give this master data, and then you can load some data in the requested quantity using that file, CSV file you already have in your that RDS documents. You just have to load it, and once you load it, you will see that the quantities are will be appearing here, and you can load some values in the confirmed and delivered quantity as well, because these are the ones you have taken it in your algorithm. So yeah, so this is how you can just implement the demand sensing stuff and understand it. Now, another thing what I want to discuss is, um, in uh, yeah, if some new products are coming in, right, how do we manage those new products, right? Because whatever products we have calculated the history, we have calculated the forecast, does have some kind of historical data in place, right? Whether it is a sense demand or it is a stats forecast, right? Now understand that this is not IBP 100 product, which is very much now quite stable into the market, but this is something new. Let's see that if we can create any new product. So I'm going to the master data. I'll go to edit. Let me take this product, and I can also take location product. And sorry, let me go inside this master data. So there are so many products already. Let me do one thing. Let me just copy this IVP 100, Control C, and put it here. This is version 1. Let's say that this is my new product, which is version 1. This is under B, and this new version coming up. So what we are trying to learn now is, if we have a new product, right, which has just entered into the market, which does not have any kind of historical values. So how do we plan that kind of new introduced product? So that process, guys, remember, that is known as, you can call it as NPI process. You will hear that term. NPI means new product introduction. So how do you deal with that? So now let me just take one of the location, and then so at this location ID, maybe this product is getting manufactured at 6210, and our product was version 1. Okay, so I'm just saving it. So let's say that this product is meant for a customer. So our was 100, version 1, and customer I can take the same customer as IBP 100, this one. It is VERS capital. Okay, so let's also see the key figure data. Product location customer, and I believe we should have some actuals quantity for the old product for sure. Uh, Actuals quantity for product ID as IBP 100, and we will not have anything for this, so let's create some space. Yeah, so we do have. Okay, did I do the edit option? No. Yeah, so now let me just, let me not make any actuals quantity, but that combination, let me just try to make it so that the planning objects are created with this new. This is our version 1, and we have taken it with this one, and the customer was, this product is linked to this customer. Okay, yeah, so what we are trying to do now is, so managing new products which are introduced into the market. So in IBP, we have an app which is called as Manage Product Life Cycle. This is the name of the app that you will use to implement the functionality wherever there are new products getting introduced. How do we calculate the forecast of that? So what we have to do is, the concept is, you need to take the reference product. It is similar in nature of the new product which is coming in. So let's say that iPhone 13, uh, that Pro Max, right? That's the version it has come. So it may take the earlier version as its reference product, copy the history of that one into the new product, and then calculate the forecast for the new product, right? So there may be some promotional activities that will go on for the new product. All that will be considered on the baseline forecast whatever we are creating, but we need at least some baseline to be created, right? So we need a uh, reference product for which we can reference product for which we can consider the history to calculate the forecast for the newly introduced product. So how is the cycle of a new product which is coming in? So first, it will take some time to get matured, and then it will have some maturity phase where it will just um, have some kind of sales into the market. It will go to the peak, and then slowly it will come down because there will be some new version of it which is coming into the market, right? So depending on the industry, the life cycle will depend. It will be sometimes very short, right? In terms of electronic industry, definitely the tech things have a very short span of life cycle. It will just come, it will stay there for some time, and then within few months you will see that the demand is now declining for that, because some competitors have come up with the new products, or the same company have come up with some new versions with some new features. So it will be like that. So just a moment, guys, 1 second. mm, just 1 minute. Let me see that slide where it is. Okay, so again the screen is shared. So this is the um, topic that we are considering now. Some new version of iPhone has come. That's the latest version. So we would take the reference product, which was similar. So how is the cycle? It is just starting. So starting phase is called as phase in. It just started, and then this one goes to the peak, which is the maturity phase, and then it is going out, which is obsolete phase, right? Phase out. So one is phase in, another is phase out. These are the two important phases in this, and the app name is this one. So this is what the notes are already taken, and this is the diagram. The phase in start, and then the market introduction is happening, growth is happening, stability comes for some time, and then the sales will decline, and then end of the life will come, and then when that end of the life date will reach, it will go for the phase out, then some new product will come. So it keeps on going on, right? So if I go to the app called as, let me go it here, duplicate. So the app name is Manage Product Lifecycle. Okay, so here it is asking for the planning area first. So let's select the planning area. So now here it is asking us that reference product ID and for which product I want to, manage the product lifecycle, right? The new product. So I'm going to add, and I have two options. I can do single product assignment, or if I have multiple, I can do that as well. You know, I have one, two, three, four, five products which are newly introduced, so I can just choose the multiple one. If I want to do the manage life cycle for a single product, I can click on single, and which is that product ID. So I'll just choose that. So this is the new version that we have just created, which has nothing. So launch dimension. So based on what you want to launch it. So for example, if you are launching a particular product, you know, only for a specific set of customer, then your launch dimension may become, customer ID. But normally you will see that launch dimension, uh, because you are launching a product, so it can be the product ID. So let me just choose. So there are many options, all the attributes you can uh, take it as your launch dimension. So for this I want to take it as a product ID and then say OK. And now, reference product it is taking as this one. Is it correct? No, because reference product is something which is already established. I want to take that. So I don't want this. So what I'll do is I'll delete it and then add which I need it. So reference product ID. So reference product what I want to take is this IBP 100, because now for this reference, now this new version has come. So let's think in that way. This is iPhone 12 and now this iPhone 13 has come. So now I'm saying okay. And now it is asking, so how much weight you want to put in the historical value, right? For example, this has the history. You want to consider 100% of this particular history to the new product, or you want to consider 50% of it. 50% means, so for example, the actual quantity is 1148 for this week. If I say 50%, it will take 500 something, the half of it. 820, the half of it, 410. If I take 100%, it will take the full amount. So let's say that it is 100%. And then, if I want to give it from which date to which date I want to copy that history for the reference product to the new product. So guys, pay attention. This is not that complicated, but this is important. So let's say that from 2021 onward, November, I want to put the history and it is valid to today. Offset, if I do not want to consider, in the past some periods, I can just give that number here, number of days, if I do not want to consider. Starting from current, it will take For example, I've given here 5. So starting from today, it will just consider 5 days back and it won't consider the history. It won't copy it. But I don't want to do that. I'll say OK. So this is what I've given here, and that's it. And then if I go to the another tab, which is the forecast dates, so now you see that this is already coming up. So now you can relate it. This is phase in curve. So how you want to take this phase in curve? So phase in curve can be, in the linear form. So if you see this diagram, guys, in the linear form, or it can be the sublinear form. It is just going like this and then coming up here. So sublinear is almost linear, but uh, it's not exactly linear in shape. So y is equal to ax plus b is something, the definition of a straight line, if you remember your mathematics. So that is nothing but that is coming as a linear line like this somewhere. So it is growing. So this is what you have, the linear, the sublinear, or it is the superlinear of it. So for example, I want to take it as linear, and forecast start is from today, and phase in start date. So phase in start date is something that, phase in start date, you can say starting from today it is launching, and then it will end, let's say after 2 months or after 6 months, right? So let's say that in November, December, March. So March 14, 2023. So after a few months, it will decline, and then phase out phase is also. I'm just telling linear like this. It is coming down, and it is phase out start. Phase out start is, when that phase out decline phase will come. So if you see this diagram, you will be able to relate when that end of life is coming. So
Hey, HS, can you go to the diagram and then tell the IBP 100 and then IBP 100 version 1, just for my reference purpose?
you mean in this
This one,
diagram?
yeah. Yeah.
Yeah, this
So,
is all about now the new version, the IBP 100 version 1. We are talking about it has introduced into the market. Now it is picking the sales. It has become stable. Now at some point of time, the any version 2 is coming up, IBP 100 version 2, which is
mhm.
again a new product. And then the sales of the old one will decline. And now the new one, version 2, will become the reference for this one.
Oh, okay, okay.
So the forecast will start before the phase in start, right?
The forecast will, yeah, exactly, the phase in start, and then that is the start of its career, and then the forecast will calculate from that
Mm-hmm.
day onwards. Yeah.
Okay.
Okay. Yeah, so phase out start means when the phase out is starting. So phase out is starting, let's say from 1st November, and then phase out end is by 14th November, uh, in the future, let's say 2023, and this is also 2023. So phase out start and then phase out end is this one. So phase out also has a curve, right? Because if you see here that it is end of life, it is becoming, it is not suddenly dropping off, and then the phase out is end. So it means that from where it has started declining, from here it has started declining. So this is the start of the phase out start. It has started declining, and then
So
here
this
it
is
has totally
basically,
ended.
planner will put this based on their best judgment, correct? This is about the future. So the
Yeah,
phase out.
exactly,
Okay.
you're right, because because who are into the business, they will know that, okay, they are launching this product, and they feel that that product will go on at least for 6 months. So then after 6 months, then end of life will be there, because they already have a plan for, let's say, 3 years down the line. that they will be launching this product for 6 months, they will be producing this much, they will be consuming it into the market, then the new product will come. So like they have a plan for 3 years or so, so they have the clear visibility, so they will know that, how when the phase out they have to keep for that product, because that time they need to come up with a new product with that.
Got it.
Yeah, yeah. So let's say that some phase in curve, linear. So if you want, we can simulate also. So this is very good functionality, guys. You see here the linear curve. It is just showing me that how it is growing up, uh, you know, till here and then ending here. So this is just a simulation. Also, it will show you in the graph format. If you want to see it in the square root, quadratic, cubic, all these functions are here. So
But as for
this
the graph, there should not be any phase out starting, right? Right?
as per the graph, there should
Yeah, I
be
mean
no phase starting
phase out,
means.
right? Because that means the product is doing good, right? So there is no need to phase out.
No,
I mean
no,
the
but every product has the phase out phase, right? How much good it do, but still it will come down and it will just, uh, you know, at some point of time,
yeah, that is
you have.
there. Yeah.
Yeah. All right. So let me just save it this one. So it is telling all this product assignment has been done for the IBP reference product as this and this. So this is fine. So now this is saved. So now how do we execute the forecast for this one? The way will remain same. If I any forecast profile that I want to set up, this is the app manage forecast models. Only the difference now you see that how it will be. Now if I'm creating any forecast model in it, or let's say that let me go to the existing one. So let's see that what change I have to do to consider this. So the existing one is, let's say this is the stats model. uh, I'm going inside this. So the important point here is I need to tell to the system that consider product life cycle information. If I do that, then it will consider whatever I have given here in the manage life cycle app. It will consider that as well. So this is just a very important tick mark. If we don't do this, then our new product planning cannot be done in terms of calculation of forecast, right? So this is something that I will tick it, and I think the other ones we have already, yeah, so we have already told to the system that this automated exponential smoothing, one of the model is already there. So I'm just saving it by checking that option. That's the only change that I've done. What is that change? In the general section, we have this parameter called as consider the product lifecycle information. And by ticking it off, I'm telling to the system, consider the product lifecycle for the new products. So how do I execute it now? So before executing, let me just go here. Let me copy this. Okay. Actuals quantity, stats forecast quantity. This And let me also take this one now. Now let me execute that model. So which is that model that we have considered? We have considered the model as ZHSC stats model. So I'll just execute it here, run. So because I've tick marked that, so it should consider the new product as well. So month and forecast to be used is mm, this one. Each. So let me not give that new product, and let's see, because what we have done is this product, we have already used as a reference product to the new product version 1, right? And we have also told to the system to consider that manage. So let's see that does it consider that or not. So I'm not even giving the new product, but let's see that how does this behaves. So I'm going to the status to just check that this is running now. It is finished. Let me see if there is any filter. Yeah, so it is actually given. Just 1 second, guys. I'll be back. Somebody's on the door. Just a minute. Yeah, sorry, guys. Okay, I'm back. So, what I was expecting that the this one we have already saved it, right? Is there anything which is left because it hasn't considered? I saved it, and yeah, this is already active. I don't have to activate it. IVP 100 I've taken, everything is correct. Hmm. Maybe I think I'm missing something. At the food forecast dates, everything is fine. Launch dimension also I have considered, and the main thing is that this is now, yeah. So I've taken weighting factor as 100%. So it means that 100% it will consider the history of this starting from 2021 14. So we should have some history of this in 2021. Yeah, 2020 onwards we have the history. So definitely 2021 October month history is there. So it should actually consider that history as well. Let me see if I can find something in the uh, just 2 more minutes, guys. Well, we are at the end of this topic. Otherwise, we'll continue in the next session. This one. Hasn't it considered? I think it hasn't considered that it is double exponential smoothing by. Just 1 second. We are taking the right. Okay, we have taken automated exponential smoothing. That's fine, but I don't think that it has considered the uh, parameter called as this one. This one we already saved it. So let me do one thing. Let me just because we have just changed it, right? Let me just disconnect, log on again. 2 more minutes, guys. It's okay, right? Can you say yes? You're not saying yes, right?
Yeah, it's okay.
Okay, so let me quickly run now because what I was thinking that whatever changes we did, it did not consider that flag. That is what I was thinking. So this is the one, and each unit. Yeah, let it run and then we see.
You were expecting to see IBP 100 version 1 product here?
Yeah, exactly. So yeah, I think what should I do is I need to execute the forecast for the new product, right? So that it can consider the
I can
old
copy the old
product.
one and put it on the new one, right? That's what I think.
Yeah, yeah. Because if I execute the forecast for the new product, that's how it should consider the history of the old product and then take the forecast of the new one because it will not have its own history. Yeah. Let's do that. So let me quickly go here. We are at the climax, guys. So just here. And now let me just take the same model, this one. I'm executing it not for the old product. Now I want to calculate the forecast of the new product which doesn't have the history. So I should not put this filter. I should put that new product here, which is this one, not this one, and say OK and then run. So now I think this, what it should do is, it has already that tick mark that manage the forecast life cycle. So what it will do, it will just go that in that app, see this product there in this app here, and then it will see that for this product, which is that reference product. This is the reference product that I'm talking about for this product. Which is the reference product? The reference product is this. It will copy the 100% history from 2021 onwards. 2021 November onwards, it will copy the history for an year, and then that's how it should calculate the forecast for this. So now let us just see if this has finished. Let me just go to the app. It has finished, but it hasn't given anything. Maybe I think those combinations are not generated. The product, location, customer, actuals, quantity. Yeah, I think that combination is not generated. Let me do one thing. Product, location, and this one. Uh, Let me do one thing. The product, customer, and location for the new product. I'll just take only the new product. I think this combinations are not generated. That's why. Because this is just entered into the market. What will happen, in the real time, because so many jobs will run, this combinations will automatically generate. But in this case, we'll try to do the planning objects, new planning object, and the product is this one, and customer ID we have taken this one, and location ID. This I don't need, IBP 100, and location ID is this one we have taken 6210. Let me say add. Hmm, it's not letting me generate the combinations, but nevertheless, what we'll do is we will continue this exercise because these combinations are not generated. That's why it was not giving any. Uh, it was not uh, considering any data. I think that's the reason it has not calculated for the new product. But let us consider this exercise in our next session. We'll continue from there. Don't worry.
Okay, thank you.
Yeah. And bye for now. And yeah, we'll meet
Thank
again
you.
in
Bye.
our
Bye.
new session.